Okay, John, we're about ready. So this is the first official International Linux Users Group meeting where we're going to be talking about open source and radios. And John Alexander will being our host here and talk about how we actually do cool radio stuff on Linux. So go ahead, John.
Oh no, thanks for that, Peter. First of all, thanks very much for everyone to come in. It looks like well attended. So I hope people are suitably entertained and also can learn something. I have tried. Yeah, I sort of suggested the topic was it some time ago now to Peter, and then all of a sudden we had to deliver, and as you do, and basically I thought, well, how do we kind of square this to both a radio and or a Linux audience? Go over the areas that people wanted and not necessarily bog down on the detail. So what I've done in actual fact is sort of work out, just a few little points, bullet points, as you can see here. And then we're going to run through those. You'll have to put up a couple of pages of text, and then we've got pretty pictures of software and machines and things. Unfortunately, no animated or movies, such, but I could discuss those later on. I don't know what people would prefer to do. I think probably best at the end, Peter.
That's really fully up to you. We can certainly
Yeah,
stop
it's
in the
probably
middle if you
best
want
at the
to.
end. I think if somebody has some really burning question, then maybe think put the hands up, or if you've got the equivalent there,
Yeah,
I could probably see that. Or if you see that, then Peter, can you break in for me?
I will do that, and that's a good point. If you are not used to Google Meet, there's a little hand symbol in the bottom of your screen that let us know that you want to talk, and we can then make a break, or you can put it in chat, and I'm going to watch the chat and maybe do that for you if you don't feel comfortable going on off mute.
Okay. Thanks again, Peter. Yeah, so what I've done here is basically I've just tried to put together some of my thoughts on, as I say, open source and radio technology. So if you're coming as a ham, or you're coming from as a interested Linux person, then yeah, and you should get something out of this, and hopefully it's more of a topic of for discussion. So we're going to go over it at sort of, as I say, a high level view, but then I'm going to talk about a few little key points, and that's about it. And then we'll come to a Q&A afterwards, and I think that's probably the best way of doing it. In as far as I'm talking, I'll probably only put, I don't know, 10 items of software in there, not all of which are genuine public. They're probably free, but not necessarily open source. The ones that are basically locked to a piece of hardware, right? And essentially, not much use otherwise, right? And that's just to talk about that particular subject. So after we go through those, it should raise enough questions possibly for others to come on in at the end and actually see interact. So it's very much a Q&A based at the end type session. Okay. Right. So as I say here, what is ham radio? Why does it cross over the, what's the open source guy? Well, why do people who are open source or Linux guys are quite often ham radio guys? Why they're both? Is it free or open source? We just want to know why people want it to work. So I'm not going to go through the whole of the list here because I'm sure everyone can read. If anyone can't read anything particularly there, then sort of please tell me. But I think that's pretty much it's all text, so you can pretty get to that. All right, and as I say, ham radio, and it is a science-based hobby, and I think very much and if you go to any of the groups in charge of whether it be RSGB in the UK, ARL in the US, they'll be going, it's a science-based hobby, right? And you'll be basically you're in charge of learning for yourself. It's learning and experimentation. So this is having fun, but also learning while you're having fun. All right. So the kind of things you might learn now about, say, antenna design, electronics, how to set up your radio, right? And then equipment is in the shack. I hate that word because it is so, but it is quite humorous. It's a cringe-worthy kind of word, but that's where you your base all your equipment, and have you trying to improve that and improve your efficacy, right? And in the terms of doing that, you'll be sort of learning physics in terms of radio reflections, buildings, your reflection of space, weather, different layers of the ionosphere, right? So the interactions with the sun, and if everyone ever sees the news or hears the news coming from the ARL or RSGB, you'll see they actually spend a significant amount of time talking about the weather and the sun in particular. So all of a sudden you think, oh, what's all this about radio? And in actual fact, it's all about the weather, right? And that's why, because it's so critical to propagation and probably one of the most difficult parts to understand, and probably gives you the best benefit as well. So, a good understanding with that is something that's important, right? And other sort of things that people might be interested in would say, like, you're talking to remote devices and repeaters, so people talk to both internet and normal non-connected repeaters. So you can talk to remote sites via an intermediate, that's it, repeater, right? So I could talk to you in the US via a Ethernet-based, that's Ethernet, but internet-based repeater, and it does exactly what it says, right? And in the case of satellites, then voice and data telemetry, right, which might be interesting, or you may well want to just I could actually say to Alex or over there in the, I presume in the US, yes, right, and you could be I could be in there, I could be talking to you as if you're basically in the room, hopefully, right, and also send you data, but you could also be pulling data down. One example would be weather, actual weather information, which and also basically you could get there's a whole family of amateur satellites up there, right, that people have put up from various organizations, saying predominantly sort of America and Europe, but they lots of telemetry coming down for both scientific and just pictorial. So, and anyway, yeah, so as you can see, this is all pretty much multidisciplinary stuff. So you need to understand the radio, you need to understand the electronics possibly, then you also need to understand some of the small scientific efforts and weather, but also you need to know where these satellites are coming from and time them, and there's all the mechanical things of pointing the areas in the right place and getting the software to work, because obviously all those actual bits of telemetry are actually decoded with via satellites. Sorry, via actual software, right? Predominantly most open source, but some of the probably more tapped and wrapped and ready to go solutions are in fact not necessarily closed, but certainly not open source per se, and they may actually just come with to support particular devices. So that's always a thing to maybe bear in mind, right? And there's some examples of Linux devices. So we've seen obviously things like Linux in printers and Linux in obviously in your computer, Linux in your Raspberry Pis and whatever else. But this is obviously looks like very much like a radio, and that actually has a Linux board in it, right? And you can actually it has been, it's not it's meant to be hacked, but it has been hacked to support extra software. And here's a case of an SDR, right? So that's a software defined radio, right? And that's not my hand, unfortunately, but it's it's about a £200, $200 device, $230, right? And not only did it actually attaches to a computer, but it is actually a complete computer in itself and will operate free of the machinery, so you can actually run it as if it was in your hand there, just merely powering that up. That's not powered at all, obviously, there, but there's actually an FPGA in there to actually do the and many times people put their own projects in. All right, so it's a Linux computer with a FPGA to do the actual heavy lifting, so you don't actually have the any trouble actually doing the decode. And people actually use that for satellite TV, actually uplinks to satellites. All right, and they stick all the code in there, so you only need a Raspberry Pi or so to control the exercise. And this is actually an example where you might find one of those addlums inside here. All right, so this is an amateur, as it says on there, ports down digital TV transmitter. So this goes both terrestrial and also towards satellites. So we haven't got a picture of a satellite setup here, but we'll see something a bit later on. But it will allow you to see, it's probably quite a complicated device, but that's something that maybe you could build yourself. There is documentation for this. It is all open source, wiki based. Sometimes I think it may need a bit more documentation, a bit easier to read, but certainly all there. Right, and here's a total black box. Right, so there are simply thousands of these black boxes that do things. In this case, this is probably this is just a satellite decoder. Right, and I think everybody had, I think, a Hauppauge hard drive based satellite decoders, and they were they are all Linux based, but you can imagine everything from about $20 to $20,000 as a black box. All right, so really hard, a very large number of just things that never tell you what they are. And one thing to start off with is probably, obviously, the hams there will already know, but maybe not the guy coming in from Linux end of the woods. This is a license hobby. So one difference between, say, doing things with open source software or Linux, where effectively you're free to go anytime you wish, do what you want, how you want, etc. Right. Amateur radio itself is a licensed and regulated hobby, and there was just a couple of examples of organizations there. So in the UK it's actually licensed via Ofcom, and obviously in the US FCC. Right, and obviously you don't want to be upsetting those if you can. Right, but I don't think that they worry too much about, say, a few milliwatts, but when it starts getting a bit more serious, then they certainly will start to, if they have to, there's any complaints, they'll certainly come around. RSGB and the ARRL are obviously they are the organisations, the governing bodies for the actual AMs themselves. So if you're in the US, you might join the ARRL. I'm a member of the RSGB in the UK, and that's just like a representative body, really, and they're there to effectively show best practice and also organize the exams and events and conferences and all that business. And you can look up those whenever you wish. And yeah, this is the shack. This is the throwaway here, right? And the radio in the middle there. There's a lot more junk which I made sure that wasn't in the picture, right? And yeah, we got the computer which is sitting there and running all the good stuff on a quite large TV, and that's in my shed. So a very small shed, sort of 8 foot square, with all the gardening equipment and a lot of radio gear. Right, turn it on to keep it warm. And that's pretty much near the truth. Right. One thing I wanted to say beforehand is that there is commercial, out and out commercial software which will only work with, and they actually sell that software, and it'll only work with certain equipment. And this is not that, but and they are quite rare. However, there is lots of software which is essentially free, as in like no charge, and you can openly download it. But in fact, it's designed for a piece of hardware, right? And in this case, it's SDR Play, right? So we'll see what it looks like. It's only a black box at the end of the day, all right? But you can buy your SDR Play for something like $99, $100 or thereabouts, and there's several versions of it. And this is software that's designed to actually support that. So although it's free, it's designed to support this particular device best. And well, they still actually originally this came as an open source package or an open package and supported different hardware, and then they've taken it on board when it got dropped. Right, and they've done a lot of work on there, and as you can see, that's a very busy screen, and I don't think that's the whole of the actual Windows U. That's the default, so they certainly pack it out there. But it's an interesting thing to see that there's that kind of halfway house between actually being a pay for, but this is free, but not open source. And this is a similar idea. I mean, this is a logo. So I was in the competition at the beginning of the week, and this is a little window from there. So you'll log your information in there, who you've talked to, the signal reports, call signs, and then I'm going to make my application and maybe win something. In actual fact, I'm not going to win anything because I'm out of about 200 people. I'm about 2/3 down the list. So I'm not going to win anything this week, but that is again free, but not open source. And to be honest, I think that at the moment there is nobody who's doing. If someone wants to write one, then that's great. I'll be all up for that. And at the moment, it's not a true open source logger. There's lots of them which are kind of broken and a bit funky. But the ones that are most finished, like Minos, N1MM, etc., they're free, but not open source. And this is actually supporting this is an example of something supporting a particular piece of hardware, which I don't have. So that's why the big, massive black square in the middle, telling me that I really ought to go and buy sort of $1,500 worth of software, hardware rather. This is for a DX10 Yaesu big radio, right? So this supports that, so you can run this remotely, right? And just shout at the laptop rather than shout at the microphone, right? And you can run this remotely. So your big remote button there, if you see at the top middle, right? And you could be anywhere on the internet and talk to the actual hardware, and that is completely proprietary. And again, this is proprietary, but again, to support a specific hardware. And I haven't got the thing with me, unfortunately. It's just a handheld, so I'm sure anyone who's got probably almost all the handhelds have something to support them. And this is basically to set some channels up to program the device. There's a whole load of software there, setting up the APRS and various modes, but it's just there. Doesn't matter what it is, but it's there to support a particular device, and that's proprietary. There is some generic software for this called Chirp, which I haven't actually mentioned here, but generally speaking, there's probably one or two features that are not supported there. So you'd end up using this, and it's only for occasional use. This particular one is for setting up, so you're not continually doing that, so it doesn't really matter too much. Right, so just to before we're talking about proprietary software, and then we're back into some rather nice just to show that there is some very nice open source software. This is SDR Angel. And anyone, I've had a little go with this, and I've certainly, as far as I've got with it so far, I would wholeheartedly recommend it. All right, and it shows the sort of quality that you can produce, software you can produce for open source generic devices. So it's not locked to a particular device, it's not locked to a particular vendor or even a particular platform. So I think this one's probably picture's been taken off a Windows machine, so it normally supports Windows, Linux, and via Brew, I believe it supports Macintosh, and it has a load of functions within there to decode. In this instance, quite impressively, it's decoding sorry, not TV, but weather satellite. Hello there. Oh, sorry. Yeah, Peter, that's no problem. If anyone asks, put it on the raise the hand. Yeah, so you put it in there. This is actually decoding weather satellites, and you can see there's NOAA 18. So this is a US satellite being put up by the US government specifically to support the weather not decoding, but certainly weather producing weather images. We're interested here. I can tell it's not the high resolution image. This is comparatively a low resolution image. If you look here, I don't think you can actually move my mouse on this thing, but it will. If you see the central data, you can see the peaks, and each one of those peaks is a given frequency. It's representing the the actual data, which I think we can see next. No, it's not back. I'll show you those later on. But it's just basically it's a each one of those peaks is a shade of grey, right, on the on the actual image, right. So there's very discrete levels. Right. I think the actual standard was introduced in the 60s. So Jeff, what is the name of decoder? I think if you look under APT, yeah, then this is SDR Angel decoding APT transmissions around about sort of, I think it does say there 137 megahertz. So you can use little dongles, which we'll show you later, to do this. I won't discuss how to set it up because it sort of will be, it's quite specific, but people are interested. I could do further talks specifically on those actual items. So if you find what you like, what you're interested in, then by all means, please tell us at the end, and we'll actually see about doing something more specific. So this is an overlook view. All right. So SDR Angel. All right. I actually I did initially think this was just a merely free, but it is actually completely open source. So you can go on to GitHub and actually download this or contribute. So when we're talking about what you can contribute to, I mean, at the end of the day, merely testing, right, is, it's a valid contribution. So if you haven't got programming skills and you say, oh, I'm just interested in the radio, I'm not interested in the software side, that's not something I really know much about, but you can test that, and they've probably been, yeah, that sounds right. Yes, thanks very much, Jeff. And this has actually been around for a very long time. This is GQRX. It does say what it is, but I just realized it's very small text on the top of that window. So this is written by chap in Denmark. I think I've met him a few times, Mr. Siest. And I think originally the whole suite was written to support the open, I guess right, to the rocketry one. So I think what it was, it's the there's actually an open source space launch. I think I'm trying to think what it is. Stockholm. Is it Stockholm? Not Stockholm. What's the capital? You should know, Peter. Capital Denmark. Gone straight out of my head there.
Well, that will be Copenhagen, not Stockholm, but I get what you mean.
Yeah. So anyway, it's Yes, it's definitely not Stockholm, right? But they actually run a open source rocketry, and they're producing open source rocket engines and a suborbital actual rocket. And to get the telemetry back, there is a whole host of software, right? And they're all open sourced in themselves. So this is actually just a radio, right? And a lot of projects use this just to get the data off the STR and get it into the computer, so you can actually send this out through a network socket, and then you can further decode it with whatever you've got to hand, or you can send it through the Linux sound system. Either way, it allows you to pick this up. In this instance, I think you just find it's some FM radio, and there's nothing particularly fantastic about there. But if you wanted to analyze that, I think if you looked at some of the actual data, I think there's probably some data on that one on the left on the carrier, so you can actually take that over, redirect the output, and then have it processed by your own application if that's what you wanted to do. But that's a very well known application, and by the same actual author, right? Is a thing called gpredict, and I thought we'd have that there. And there's a load of little windows, but obviously I'm not going to sort of crowd the screen with too much going on. All right, and if you see there, you can basically you can select your actual let's put this right, satellites of choice. All right, and you can see each of those yellows, and are not circles, probably more circular on an actual globe, but here there's some kind of sort of ellipse, and that's the actual footprint of the satellite as they move overhead. So if you're actually trying to download anything from the given satellite, you can actually see when they're coming over. And this one here, I mean, this is AO-73, so it's an American amateur satellite.
So how come there's no coverage on the southern hemisphere?
I think that was just random chance. Right, if you see the one that just says, yeah, no, there's if you put everything on there, there would be there'd be no room to read the writing for certain. Right, it's just one that was taken at the time, you know, and yeah, I think what you'll find is that obviously if you look at, say, the ones say AO-91, I think there's a NOAA. Can't see the NOAA satellite on there. They actually are in what they call presumably be sun synchronous, and they'll actually go over the top. So you'll actually see certain satellites going almost round and round and round, slowly processing twice a day around the Earth, and we actually see one which is doing it there, and that's the AO-91 on the top, and because it's right up on the top, it's looking down upon the actual North Pole. There'll be correspondingly times when it's looking down on the South Pole. Right, and ones that don't actually go down very far or come up is the ISS. Right, just out of interest there, Peter, it's limited. I don't want the actual angle. I think it's like maybe plus or minus 60 degrees from the equator, and they've limited that so the actual Russian launch vehicles can actually get to it. And when it was constructed, it made it easy for the space shuttle to put it there. But once it's there, it's pretty much there, and there's little benefit in shunting it out so it's go any further. Not least because they won't get any visits from any satellite Russian satellite vehicles otherwise. So from their launch positions, they have limited views. But anyway, this will also actually control your radio. And let's go back. So it will control that, for example, and tune it. And as things are moving, because of the Doppler shift, this will actually keep your radio, whatever type, actually actually tuned up, and it'll also point your antenna So it'll both point the antenna, tune the radio, it'll queue up the actual and the next, I think it's 7 passes or whatever you got there. So if you wanted to say listen to the ISS, it would make sure you're actually attached to the right transponder at the right frequency at the right time as it slowly moves overhead, because obviously this one in this case, all those satellites are in low Earth orbit and as such move. Right, and just as another example of this is all the open source. This is a piece of software called FL Digi. Right, and this is available for Mac, Linux, and Windows. Right, and this has been around for a very long length of time now. Right, and it doesn't control the radio itself directly. Right, although there is actually a sort of an ancillary program which is called Hamrig, which will actually allow you to do that. Right, but in actual fact, there is probably actually talking to Hamrig. That's what the frequency displays actually sorted out there. But it'll allow you to deal with about 30, 40 different modes. At the moment, I think it's trying to do RTTY probably, right, or maybe CW, so Morse code. But that will support a large number of data modes on the available on the airwaves at the moment, including things like the actual satellite, obviously the satellite stuff, but also the radio beacons and telemetry from the marine sources. So it's quite interesting to see what's coming through on AM. So you can actually listen to the even though you're inland, you can hear the actual various weather stations and also authorities, coastal authorities, actually giving out their information. So it's pretty interesting. And also the maps. So there's also a set of mapping. I'm sure we've seen sort of, was it the deadliest catch and whatever, and pulling off the weather map. And this would actually decode that. So you could do the same yourself, just in case you want to go fishing, of course. There's also just data produced for one ham for another ham. Right, and these are an example of this is from some of this case is FT8, and this software called WSJTX is written by the developer of FT8 and FT4 and a whole load of other protocols. Right, and these are people from around the world talking away. So if you look here, I think we've got some people: France, Sweden, Ukraine, Taiwan, France, and probably, and yeah, this is obviously mostly European, but we obviously got Philippines and Bahamas there as well. So you can, as well as actually just using the microphone to actually communicate, or maybe a Morse key. I'm sorry, I've once seen a Morse key, and I think some people may do that. I certainly don't, unfortunately. But anybody can actually use the computer and this open source software to communicate across, well, it's basically globally across any bands. This will be operable all the way into microwaves, but mostly at low frequencies, more or less the same sort of frequencies that shortwave. And this has very high, what they call noise immunity or signal to noise. Well, you can operate with very low signal to noise, actually below the noise. So if you're actually listening to this, you may not actually hear a given signal, but there could be actually what they say about 20, 30 decibels, and that would be sort of between 100,000 times quieter than the noise. So very low signals can be picked up and dealt with digitally, and you're not deafened by the noise as you're going through. But some people like it, some people don't like it, and that's what's about there. I think this one was actually the ADSB. Just make sure that was right. And that's the actual location data and chassis numbers, etc., basic information, right, for vehicle, for aircraft. So you if you have an airplane, right, not only are you might be dealt with actually using the radar, so you can be seen using the radar. You have secondary, which is the data you volunteer, right, periodically, and also at any point when the radar beam goes past, they actually give this data, right. And I don't know where this is, right, but yeah, there's you can see there's the flight number, there's a hex number which actually represents the country that the plane is from, registered to, but also the actual plane itself, and then the flights, which obviously the flights that you might recognize. So if you're going to US or over to UK, you may see some particular flights you might recognize, and obviously basic things like directions, speed, and heading, and altitude. Sorry. All right, but that's not very easy to decode. It's interesting, but it will allow you to basically debug. I think this is probably more useful for debugging or for pushing out to other applications. It does sit on a port as a web server, and if we go to the next one, this is the original web provision for this software. So this is what the original web software used to look like. So you're running the actual dump 1090 in the actual daemon, as a Linux daemon. This is all open source. It's running on Linux in particular, but also runs on Windows, that I know of. It sits on a TCP port. So as you remember, in a lot of software, there's the FlightAware, which allows you to upload this data to a central database that FlightAware run. But I think they if you want to actually see what's going on, most people want to see what's going on probably locally. And I think if you're not actually a part of the original cadre of updaters, you probably find that your area is already supported quite well, so they want you to pay for the data, right? But in this case, this is entirely held on your network or even on your own machine, and you just attach. I'm sorry,
John, did you say this data came directly from the airplane's own transponders, or these aggregated?
Yeah. So this is so the previous software, right? And this is dump 1090, yeah. Which 1090 is the frequency, all right, 1090 megahertz, all right. It's from the ADS-B transponder on the aircraft, yeah. So that is the raw data being picked up by your SDR or your other radio, whatever it is, but it's not very readable, all told. So I suggest that you go to ask it to produce a TCP socket and go to the web, and it actually produces a web page like that. So that is basically a web representation of the data given previously, yeah. And it also does data lookups. I think for obviously the size of the relative size of the airplane or the type of airplane, but also I believe also forget the flights. But if you look a bit at it, it will bring back pictures of the aircraft, very much like FlightAware. All right, but it pulls back from different data sources or provides links into them, and obviously the web page does all the work then. Any questions there, Peter?
No, I just want to make sure that I understood where the source came from.
Yeah. So this is all open source. This has been around for well over 10 years. All right, and that probably the easiest way with this would be sort of like the RTL dongles that everyone's talking about, and you'll see one or two of those later on. Right, and that will just plug into, say, your computer, or if you're going to dedicate something to it, like a laptop or Raspberry Pi or whatever, You can just access that anywhere on the network. And yeah, just going on there, more different types of data. Obviously, the radio, as I say here, radio information is everywhere. So it really is everywhere, right? And this is actually what they call POXAG, or in actual fact, this is what you get for the actual. What am I thinking there? The go back. Yeah, that's what I think. Pages. That's what it is. I couldn't think of the word. Sorry, give them about that. So this is pager data. So quite often, if you're receiving anything else, you'll actually be deafened by pager transponders. They're incredibly powerful and they penetrate buildings really well, right? And this particular one seems to be out in the UHF, but around in the UK in particular, they're all in VHF, which is about the same as a bit higher than the actual, say, FM broadcast. So it's in that kind of zone for those who might not know the different bands. But they're incredibly strong, and you might think, well, you know, pages, they're so 80s, 90s, yeah. But I can assure you they are still going strong. As you can see there, they're just burying the needle for everything, right? And yeah, generally speaking, ambulances, fire engines, doctors, that kind of thing, right? There's, you know, and you know, I would say one note of caution there is actually decoding it, strictly speaking, is probably illegal. Certainly acting on it's illegal, right? And if you any knowledge gained on there, right? So there's no information on there, right? And they don't like to be told that they are insecure, but it is insecure, right? And there's bits of information there. So this is like the dump from that data set. Someone's sampled that audio and just played it back offline to a piece of software called Multimon NG. It does do other protocols, but yeah, the ones I remember offhand will just say are basically various pager protocols. Okay. Any questions there, actually? Okay.
I mean, only one, and this might just be where you're getting your images from. It seems fairly Windowsy what you've shown so far. So how much is the usual or the
Well,
users
this one
on Linux?
I would say most of them are Linux, and I think you find on. Let's go back there. That's Linux. I really wouldn't know what that was, because that's obviously browser based, but that runs on Linux. That's a Windows based. Obviously, done 1090s multi-platform, so Mac, Linux, and Windows. Go back again. That's Mac, Linux, and Windows. Same with this. So yeah, if you see a Windows dump and you say, well, this is meant to be a Linux thing or an open source thing, then yeah, you can pretty much guarantee that probably all three. And this is just a browser, so it could be anything you like on the browser, right? And go back. So I don't know what that one is. I think I would say because there is a pipe in there, so I can imagine that's actually a Linux command line or something. Right. Is that okay there, Peter?
Yeah.
Yeah, great. So anyway, moving on. So actually, we're talking about maybe doing some software yourself. So you can actually write at a very low level and talk to the hardware, right? But that's probably not the way you want to go. That's if you're doing that, you're doing that already. So coming into it, you might want to look at something like the actual GNU radio. All right, and there's a few examples here of GNU radio. All right, so this is an application in GNU radio. And GNU radio will allow you to write applications, which essentially you can almost tap and wrap and produce a runtime separate to the actual GNU Radio Suite itself. So if you go back here to GQRX, I believe there's actually some of this presentation, the actual screen information and some of the decode is actually a part written in GNU Radio, and it's a multi everything platform. So multi-platform is in terms of Linux, Windows, Mac, some other things, but also multiple hardware. It's completely agnostic. You can actually process files, just literally put data from somewhere else and process a file at non-real time, or you can actually even process data off the network. So you can have a radio system or audio system, anywhere, a source of data on the network, and you can actually pull that off and process it, and you can write code. So each one of these each one of those objects on there, so that the volume, the actual graphic, the audio connection, RF gain, all these things would be actual objects that they've placed down on a panel, right? So you can actually generate your own application. I don't know what that one is actually, but so it looks like, by the sounds of things, it's some kind of data from a radio station. I don't know if you can actually read that at all, Peter, but this is how you would program such an application. So this is scratch for a radio. So as you can see, there's lots of graphs and interconnect.
It looks like the node editor in Blender.
Pardon, sorry?
It looks like the node editor in Blender.
Yeah, quite likely. Yeah. In all cases, each one of these nodes are connected to other nodes, right? And the data flow would be from the source, which in this case is on the far left, and to the sink on the far right. And you can have various sources and sinks, and each block is connected to the next block via the actual data ports, which you can actually see the little squares on the end there, and you can just connect them. Literally, you can drag and drop a connection between the two, right? And at that point, the data will flow between them. So at each point, you you connect those data, and you might have to change data types. So there is facilities for changing, say, between floats and reels and the different packages of data. So there's lots of if you look on the right hand side here, there's lots of libraries where which are supplied, or you can actually incorporate open source pre-done libraries. All right, so I mean, you've got I'm just looking there between various different modulation types, so you can actually do your own Wi-Fi if you had the computing power there. You can obviously digital TV, certainly stuff on there. Also connection to various different types, special libraries for SDRs. All right, these are quite, I think, probably quite terse, and as far as like if you really need to see how examples and how they work and understand what you want to do, right, it doesn't take even though obviously this is quite a nice way of connecting logically the blocks. Each block is quite complex, and you can write your own custom blocks in either Python or C, right? And they will appear on here as libraries, and you can use those. But it's certainly not an easy game, that's for certain. So you might find that even a small set of processing tasks will actually take most of this screen. I don't know what this one is doing. I think this one's just got a random source by the looks of it. So it's just just an example. All right, there might be a few questions on that one. Does anyone have any questions?
Don't be shy, guys.
Okay, we'll keep that to the end anyway. So, but as you can see, you can just load that. It's called GRC GNU Radio Companion that tunes FM radio. That was probably GQRX, I think, probably. If it just had the heat map on there and the waterfall, that's probably GQRX. That's definitely free. Okay. Also, STR Angel, which does a lot more. That's also a open source application. So very much depends on what you want to do. And it's another example. It's not very good resolution actually looking at it, but so this is an application that someone has created. All right, you've got the different windows there and the different panels. All right, so at the bottom, at the top left, you've got a basically an oscilloscope view in time, and then at the bottom you've got the view probably on the same data actually. All right, which is the in FFT, so it's like a waveform view, so a frequency view. You might see that on certain radios. So you're going to have a band plan or band viewer. All right, so that's a view of just on that, quite closely on that particular data, and the other one's like a phase plot, which will show. I think that's a constellation pattern. All right, for the data that they're going to decode. And as you can see there, all right, although you can see the distinct areas are pretty close together, which probably means that there's a lot of noise involved in that signal. All right. So that is GNU radio. We can go into that. We could spend hours upon GNU radio, and I'm deliberately not doing that because, just purely and solely a taster to see what what you can actually, what is available, what you can do. Right, and here's another one of my favorites, and this is a thing called JAERO. JAERO, amongst other things, will actually decode data from Inmarsat, I believe, certainly L-band. So this is data sent by aircraft up to the satellite to respond, basically go back to base. All right, and this will have technical data on, say, engine, chassis number, vehicle status, where you're going, messages, all right, etc. All right, and just as an aside, the most popular message sent by ACARS is the toilet's broken. So you have all this advanced machinery worth hundreds of millions of dollars, right? And that they this is basically what they send. But of course, I don't know if anyone's noticed when you land in. Quite often the engineers there at the door waiting for you. I don't know if anyone's noticed that, but I certainly have. And you ever wondered why the engineer knows what's wrong? And this is why, because they they send this data not for your benefit to decode it, right, but for the engineer at the airport, right, to reduce time, so they haven't got to actually work out or be told. It's already there, and they can just walk up there and fix what's wrong. Right, and I'll show you what they have a bit later on. So this is an example of the antenna they've used to pick up that information. Right, so this one's actually no antenna, not or certainly no dish. Right, it's a GPS. It's a GPS antenna, right, with the GP, like some of these, but a bit bigger, right, and it's just sitting on a bit of metal sheet to act as a ground plane, right, and that's just, they're literally just a lump of metal, just a sheet of metal, and the amplifier's there. So they've actually repurposed the GPS there and gutted it and just using the amplifier, the actual antenna itself, and I probably removed the filter to allow that to be done. Right. So it's very much something you can do yourself, and you can get you can just buy these antennas anyway for 30-40, but these ones here will be like $2, but you have to do some work. But if you just fancy probably a better antenna, but someone's already done that work for you, and you want it in a box, then about $40, something like that. And if someone doing gone a bit more high tech, right, but not very much more so, and that's the dish. And if you look on there, there's still on the right hand side at the focus, there is the that same little antenna or something very similar on a with a little very small reflector at the back. So this can be all very hokey looking. You could, it's not like super high tech. You could do this yourself, right? And it's just that could be probably is a second-hand dish that's been in a skip or something. Where's the ground? The ground is actually on the. If you look at the disc at the back of the little antenna, that is the actual ground. Yeah, and there you go. And this is from another actual. This will take so J-Aero will allow to receive different bits of data of different modes. So if you look here, this is the actual bottom there. You'll see a band scope of the different channels within, but the Inmarsat is transmitting. On the right hand side, you'll see a constellation, what they say, and that's the actual data coming down. And it's there basically to allow you to get some idea of the quality of the data. If you're getting good constellation there with a nice wide open eye in the middle, then you know that the data is easily resolvable, right? And as the noise goes up, they'll become increasingly big blobs and very fuzzy, right? And at that point, you need a better aerial, or you need to move the antenna, or you need more amplification, or might not be able to get the data at all. So this is an example there. So something about Taipei. So I imagine it's someone's got that fired up in Taiwan somewhere. Before, and someone mentioned the APT, or what the decode for the weather satellites. This is there's several different sets of software, but also several different technologies. There's I think it's Meteor for the in USSR and Russia, and also the GO satellites in the US, and they use high resolution HRPT, right? And this is basically very low resolution, right? This is the old analog method, right, which still sits on the existing NOAA satellites. I don't think it will go on in the future, but this has been around since the 60s, and the actual antenna, the actual satellite only needs to store a line. If you actually see this being built up, you'll see this being built up as a line as the actual spacecraft rotates overhead. And this was an example of one of the satellites which literally goes from South Pole to North Pole and slowly proceeds around the Earth twice a day or thereabouts. And you see, obviously, I'm not quite sure what the one on the left is, but one on the right is obviously Europe, and there's even a dot somewhere near my house, so that's quite nice. This is WX to image. Right. I'm not too sure about the status of this, to be fair. Right. It's certainly downloadable as a package for many Linux distributions, but I can't remember the actual author died or became rather bored with it, or basically what it wasn't certainly out of support anyway. Right, and people have taken it over as a deceased or a no longer supported project. And you can, if you saw the other one, Peter, earlier, when they were actually piping to this piece of software, so you have this sitting in the background listening to the sound card, yeah. Or you can actually just save the data and play it back. But this is, I think this is a bit dubious to whether it's open source or not, to be fair. But it is interesting that it's generally available, and this is for Windows as well as, I might say, Mac, but certainly available for Linux, and has been around for some time. Any questions about that at all?
I mean, only that to note that, as you showed earlier, it's very slow transmission rates, so in transmitting images takes a while.
Oh, what, for the actual APT? Yeah.
Mm-hmm.
Oh, yeah. So it's only transmitted at the rate the satellite actually goes overhead. So it's not like they're just taking that image and it's immediately come down. That might say the one on the right might be 15-20 minutes worth of download. Yeah, I think that's probably what you're talking about there, Peter.
Yep.
Yeah. So that will obviously go over the Earth in its entirety in a period of 12 to 24 hours, but it will you can only receive what is actually overhead at the time for the satellite, or underneath the satellite at that time. All right, and what you will see is the top and bottoms getting increasingly noisy as this has obviously been cropped, but I've got you a very good antenna system, but normally as the actual spacecraft goes further away and is at the fringes, the top or bottom, left or right, then the amount of noise increases. So you can just generally see what that you're losing the signal path, and you can actually look on the something like gpredict, or to actually see the actual predicted, as I say, acquisition of signal, AOS, or loss of signal, and it'll say what what number of degrees to the vertical it's actually at, or between at any time, but also you know what point you're expecting to lose it or regain the signal. So yeah, so I wanted to obviously sort of a bit of a downside of some of the open source software. I mean, what we have here is actually the long min, the hardware. This is the mini tuner, actually, the hardware, right? And it's been decoded, originally supplied with by a French amateur for some Windows software, and that is essentially proprietary, although it's a free download. And he wanted to actually build this into an application as a part of a project, and that's going basically can't really embed. It's probably a Windows machine. Obviously could, but a bit more expensive. But in this instance, it's written for being rewritten. The functionality generally being rewritten for Linux in general, but specifically the Pi. You can see the Pi with its heatsink sitting there on top on the right-hand picture. All right, and that software in there is called Longmind. All just so happens that the software items are all basically named after hills that people sit up and send all this data. All right, and that is one of our local hills, written by the software is written by Heather Lamond, and she spent well over 6 months writing just the software, not the actual for the decode and networking, because the device is so complicated. And not only that she had to effectively nominally sign an NDA on that how they actually control the device. So if you're looking on the right hand side, there's a tuner in the middle, so big metal box, and that has all the compute to do decoding and tuning. and that, unfortunately, very good as it is the data for it's only available under NDA. But it was just an interesting aside that if you're writing software for devices, that these situations do exist. So and some, obviously you could try and work out what they are retrospectively from other people's software, but it's not an easy job. I mean, this took, as I say, 6 months for Heather to write as it was, right? And probably not all the time, but certainly a good proportion of time, right? And that's with the answer, essentially, with that detail. I think it's something like 5,000 registers, Peter, inside this device to be controlled. So it's not a simple thing at all, right? But once you recover the data, you can obviously on the left-hand side decode the television representation. So essentially, that's like a monitor station, which you can use the monitor of your own signal, or in this case, QO100, Oscar 100, which is a Qatari satellite out in geosynchronous orbit, which is free to use, I might add. Not so much in the US, except for maybe some very fringe areas of the East Coast. But generally speaking, from Brazil all the way around to Thailand. So that's basically a spread, a footprint based on the center of Africa, which is obviously relevant for Qatar. But anyway, that was dealt with. So it's been packaged up in such a way that people can still work on it, but they don't themselves have to go through all the inconvenience of NDAs. And just to show there, that's the actual software. So you can download that and you can build that, and the actual software itself is GPL. It's just some of the knowledge that went into it at some point was not. Any points there, Peter?
Not in particular. I mean, we can certainly have a discussion about why open source and why not, and some of the complications on it. But
well, that's what that's there for, essentially. Just to point this is, you've got hardware which is specific, and if you want it, you either have it or you don't have it. At the end of the day, if you want to maintain that purity to it, but sometimes being expedient is where we are, and this is generally available. All right, so I've been jibber jabbering about radios, and you think, well, maybe it's one that we saw earlier, right? A genuine radio with. Yes, it does. Yes, it does, Alex. We'll talk about that in a moment, maybe. All right. So these are some examples of SDRs in their bare form. Right. I think I've probably got all of these actually. On the top is the Etus at the top, which is a company. I think it's like a B200, something like that. So most of these receive only. You certainly don't need any. It's not licensing. You can receive what you like, and pretty much. And these other ones at top and bottom are actually transmit capable, and multiple channels, and maybe sort of 60-70 megahertz with a bandwidth, so they'll take an entire band and just process it in one if necessary. All right, so one in the middle is used to be about $5 until Chinese retailers worked out that people would pay a lot more for it. Now it's like in actual fact, that's probably an improved version, but there was a cheap version of that. $5 now, probably $15 or $20, $25. You could just invent your price, but that is cheap. It's not and in general, it's not an entirely cheap hobby. each one of the top and bottom one. I think the one at the top is like $800. The one at the bottom like 300, probably going up. So it's not a cheap hobby to get into transmitting with an SDR. There's other ones which are significantly cheaper, around the mark of about 200, 250, but it's not a giveaway. And they're all based on basically quite high-powered radio devices, along with a big stonking FPGA, which is like a custom logic device, which is programmed at start up with a generally some kind of binary blob, and the binary blob, you put it on there, program the device, and it can do all the heavy lifting for you in the device, and you only see the data once it's been processed to an extent which reduces the amount of data you need. For interest, I think that is the B200. That's the ETUS devices. You can have a look on Google those ETUS. They are one of the few devices or few SDRs which are actually pretty much open source, actually, in terms of both the software to drive it, the software which goes on the FPGA, so that's software in itself. I argue with software, but it's certainly code you can put up and build yourself, and also the electronics design. So you could, in theory, build your own ETUS device. I don't think it's terribly economic, and it's certainly well, it's not trivial, but you could do that. And there we go. I mean, these are a bit more realistic. So this is my SDR play, for which the SDR Sharp is SDR Uno is actually designed for predominantly, right? And I mean, I quite like the bare one when you see all the electronics, but as you can see, you're not going to get too excited about the boxes saying that they're basically a USB connection at one end and a radio connection on the other, and that's pretty much all of them, to be fair. All right, so you don't get any displays or anything funky like that. It's just some electronics in a box. It's very much an appliance in that respect. And this is about, I think this one would be about $100, probably just over. And there's about 4 or 5 variations of this to this between $100 and $200. And this is receive only, but it is very good, to be honest. And this was the one I was talking about earlier. This is the ubiquitous the ubiquitous dongle. All right, so these were TV dongles, digital video, and they have the decoder to do digital video inside them. But they decided that a lot of people with the software that they wanted to put in, like DAB, you see there it says DVB and DAB and FM, but all that decoding, they didn't want to put the hardware specialist hardware decoder in there, because obviously this is like $5 device, or it was at the time. So very sensibly, they're allowed to sample the radio waves and actually just take them directly raw into the computer via the USB. So this is receive only, and it's quite limited in a way, but it's very common. And at that price, if you need 10 of them, it's not going to break the bank. I think these are bandwidth for about 2 megahertz or so, but don't quote me on that. But so any form of data which is actually more narrow than that, then you can sample it and play with it to your heart's content, either with some of the dedicated software that I've shown there, or using GNU Radio to write your own. Right, and there is support for that massively. And this is the posh version, right, where they've actually taken exactly the same electronics or thereabouts, and got rid of the remote control, because we're not going to be using the remote control, and added the added a more accurate crystal to give really accurate frequencies and don't drift about, which is one of the as you imagine, for $5 you don't get a lot. Whoops, let's go back. So this is not very accurate and drifts around and generally does its own thing, and you put up with it because it is that price. This is a sort of, you know, about $25, something like that. I think I've got this one back when it was a bit cheaper, so you say $10-15, but you know, if you go to Amazon, it's probably nearer 25, something like that. And but it has a more accurate crystal in there, as I'm saying, that TCXO, so it's temperature compensated. So that box gets quite warm, quite nice and toasty, and as it gets hot, the things start to drift. But in this case, somewhat less so. Right, so it's a good investment. If I was going to do that, I'd certainly, well, I have done. If you're going to use it for anything, it's worth having this version. And back to more of my collection. Right, it's actually the top two devices, or top and bottom, in the original picture. And this is, you say, they're all black boxes or white boxes in this case. All right, so this is from Metis, one on the top, and you've got various, obviously, you can receive and transmit on these ones. All right, and the one underneath is from the Lime, and as you can see, that's pretty much replete with several receive and transmit channels, so you can be doing 2 or 3 things at once, or have 2 sets of antennas for diversity depending on your protocol. And this is based on a chip designed for 5G, I believe, 4G, 5G. So your base station might have one of these inside, right? And or several of these, or the equivalent. And that's what it was originally designed for, right? And the manufacturer, Lime Microsystems, I believe, Limes, and they actually created a board for anyone to use, along with the generic driver for it. And this one's the, let's call it Lime SDR. It's not the mini version which most people use, it's the full version, which is no longer available, unfortunately. And the B200 is from Metis, as we say, and that's the that's still available and supported, and is an exceptionally nice device. And there's just the back end. You see they're quite complicated. There's a lot going on, but probably not that, just, GPS locked. You can have different references in there, but at the end of the day, it just goes into, it's a device almost like a sound card, but for radio, and it just sucks it all in, does the minimal amount of processing, and shoves it out into your computer, where the software actually does most of the work. And as you can see on the bottom one, that's something I've kind of hacked together and put it into a case, so it got some kind of protection. And you can even see the copper foil. So I've actually got the copper foil out and made that case RF quiet. Anyway, so over in sort of hardware, you got hard software, and now you got the projects. So there's projects about that you can join, and they are open source. And this one of these ones is SatNogs, quite like SatNogs, right? And their premise is that there's lots of satellites about, open source or low cost satellites, and they're literally using the processing power of a phone, right? And they're all the order of 10 centimeters cubed, or multiples thereof, maybe 1 or 2 or 3 times. They're called 1U, 2U, 3U, and each one of those is 10 centimeters cubed. And they've got even Earth observation satellites from universities which are that size. I think, in actual fact, some of the, if you've seen some of the daily data given out by, say, over Ukraine or around that area, and you see the satellite imagery. Some of the companies providing that from the US, private companies are using satellites which are no bigger than this kind of size. So no bigger than your arm, really. It's quite small. And anyway, so probably not those, but certainly the amateur satellites and also the university satellites, you're providing a service to them as a actual ground station. So this is the as I said, a SatNOG's dashboard, so you can see the different satellites, the data coming through. And if you're a member, you should be able to see data, including like when's your next satellite, when that's coming out. And it will also control your radio to receive the right data, and then make sure that it gets sent off to a central repository to get processed. That's quite cute. And one other thing is also they have open source files to produce these antennas. And also the rotator, if you look inside that box in the middle, there's a set of cogs and wheels and motors and all that sort of business to rotate that rotate that antenna to make sure it points the given satellite, and that is all controlled by that software or all drivers on there. And also all the items, if you look on there, are predominantly open source, and you can make your own. So it's a very much a constructional type hobby. If you live in a no noise area, you can even use just a single vertical antenna just for this. You don't need to point it. It's only when you start having the problems to fires additional noise, that's when you start needing that bigger antenna. And if you look on there, I think it's like a helical, so you can see like a little spiral wound around the form. So that's the antenna they give you as a set of instructions. You can always join those. That's quite an interesting one to join. And probably not so much for the US really, but this is the Qatar Oscar QO 100. So Oscar is a sort of I suppose a phraseology. So Oscars would be the amateur satellites. They're all, I can't remember what the actual what it actually stands for. So, but so that's QO in the case of Qatar Oscar, or the US ones would be AO, American Oscar. Right, and there's a few others. Right, are going around, and you'll see everything from for various Oscar satellites, everything from as I say, US, South America, UK, Europe. There's also a lot from Asia and even from Saudi Arabia and some African countries. But this is a bit different in as far as when Qatar got the World Cup a few years ago, they put up they put up a satellite, a normal communication satellite, geosynchronous satellite. So it doesn't move in respect. So, you know, like your Sky TV or your satellite TV, you don't keep on moving the dish. That's because the satellite doesn't move or doesn't appear to move. And the location that is the geosynchronous orbit, which is a very expensive orbit to get to. But once you're there, you're there. Pretty much, except for some correction. And in this case, I think someone mentioned is the software for the decoding narrowband. There's projects for it, and of course you can do it with your own hardware, but you can also actually just pop on it. You can pop onto this website. This is run by the BATC. I think this is actually marked as the BAT. If you Google BATC QO100 narrowband or NB, then you'll see this, and you can quite literally just click on it. And there's lots of similar facilities all over the web called web SDRs, which means if you want to just experiment to see what's about, you can listen by literally going to a SDR somewhere in the country of note, and you can pick up the corresponding radio bands in that area with the actual SDR supports. This one is dedicated. This is actually in Goonhilly, I believe, in which is a UK commercial satellite farm, right? And but one of the actual dishes is pointing to QO100, right? And the actual organization BATC is actually providing this service where you can see what's going on, WebSDR, and decode that actually on the web without any hardware, right? But of course, it's nice to do your own if you can. And that is your own. This is the TV version of it. So that's the narrowband we saw before. This is the broadband TV. You can also do certain limited amounts of the broadband on the broadband version of the web SDR. It doesn't do the full decode, I don't believe, but because it's quite intensive. And this is somebody made this, and I'm not quite sure who is. I think this is possibly the actual software developer himself, Mr. Crump, right? And as you can see, there's a lot of hardware in there, a lot of switching. This also does lots of terrestrial TV decoding as well, so not just satellite. So if it's pointed to on a dish, it'll do that, but otherwise you can still receive beacons and go up a hillside with that thing and pick up people from hundreds of miles away. So it's not bad at all. I mean, from where we are in the UK, I think we're getting out into most of Northern Europe if necessary. So you're talking about France, Holland, Germany, etc., which is not bad at all. And let's go back over. I think we're pretty much getting to the end now. So, oh yeah, there's me on the right-hand side and some guys from the local radio club. There's Barry on the right, left, and Tony in the middle, and myself in Tony's garage. And you've got the radios in the middle, busily decoding QO100 in this instance, right? And we're all sort of thumbs up, ready to get it going. I think that's pretty much it. It's time for Q&A, so if we can sort of...
Perfect. Before I turn off the recording, I just want to ask one question.
Yep.
At some point, you did a presentation where you show how you communicated with a balloon. Is that any different equipment and all that than you're showing here?
It's using that one. It shows the software installation actually at the back end. So if I remember rightly, that was one of the Novalug talks. Yes, Peter?
Yes, I think so. It could have been on the other one, but yes.
Yeah, so that one was basically the FL Digi. On actual fact, technically, it would have been an alteration of a fork of FL Digi, called something as DFL Digi, if I remember rightly, right? And that actually had a additional bit of code in it to transmit that information straight back to Habub. So the online, it would push the data online immediately. Yeah, so it would do the decode and push that data online.
I was just curious how the equipment compared.
Oh, the equipment's basically the dongle. So you're talking about that $5 dongle, $10 dongle, whatever it is nowadays. Yeah. Mm-hmm. Right. And that's plugged into the one I was using at the time was a 15-year-old laptop. So it's not exactly pushing the boat. And then using FL Digi. Right, and it was sitting in someone's lap. The antenna was like I think there was just a mag mount sitting on top of the roof. So it's mag mount and a vertical antenna, sort of like a mobile, about $30 odd worth for that, and about $20 for the mag mount stuck on the roof. So you're driving along towards, chasing the last known location of the balloon. But the balloon itself, that's RTTY, so it's a very basic protocol. Right, it's been around. Oh, it's got. Let's say, in actual fact, I think it was originally used for sort of radio communications for the trading houses. Yeah, I think at one point I might be wrong on that, but it certainly was one of the things they used it. And they literally, you've seen those ones with you've seen like a piece of hardware and a bell jar, and they're reading it out a little strip of paper, and it says, "Oh yeah, we just lost $1 million or whatever." Yeah, right. And that's RTTY. So you're not talking super high technology, right? But it is quite. It's pretty much. I was going to say it's obsolete, but there is actually a community. There's actually a global competition based on that this weekend, I believe, and so it's still out and about. And we were transmitting on that balloon a signal about 10 milliwatts and a UHF signal about 10 milliwatts, which is all we're allowed to actually transmit in the UK, right? Because they don't want you to go around transmitting big, powerful signals out in that high up. And so, in actual fact, we got as far as the border of Germany on 10 milliwatts. So that, just for reference, is the same sort of power level as your key fob. So when you click to open your door on your car, right, it's technically, you could almost receive it in 600 miles away. Yeah, cool. That's not bad. So I think it was 600 miles, something like that. It was a long way, and I've seen people actually get as far as about 900 on that same 10 milliwatts, which I think is just plain mental. It's crazy that you can do that kind of energy.
So anyone else with questions while we have the recording going, or do you want to wait until I turn off the recording? If so, well, before I stop talking, I want to say thanks to John for doing this. This was a great talk. I learned a lot. But I want to make sure anyone else that has questions can get a chance to do that. So anyone wants to talk while we have the recording on?
I think Alex has just raised his hand.
Oh, go ahead, Alex.
Hello, can you? Oh gosh.
We can hear you.
We can hear you fine.
I'm not sure if this works. Can you hear me?
Bit of an echo now, so.
Yeah, that's an echo.
I'm sorry.
Go for it.
And now you're on mute. If you mute your speakers, you can't hear us. This is often why we suggest people using a headset. It makes this a lot easier. But anyway,
I'm sorry about that. Can you hear me?
Oh, it's perfect now. It's perfect.
Yeah, just go for it with the bits. Not too bad at all.
Sorry about the echo prior. A question with regards to the chasing weather balloons. Am I correct that the magnetic mount antenna is like a car mount antenna like you use for a citizen band radio?
Yeah. It's the mag. Basically, you buy the mag mount, yeah.
Okay. Mm-hmm.
And then you buy the antenna, and then you screw the antenna into the mag mount, and the mag mount's got a lead on it, and you takes it into the car, and then you do radio stuff on it on your laptop. Well, I don't, because I'm generally driving, but I get a guy on the riding shotgun to do all the ancillary bits as we drive along the motorway. Getting quite irate.
Other than like say a laptop, for example, I'm wondering about the possibility of something being on board in your vehicle that already connects to 12 volts DC. For example, the Odroid C4 board.
Yeah, anything like that, anything at all. It doesn't matter. It's you can the FL Digi. One of the benefits of it being open source is that you can, if it doesn't exist as a download for you or tapped and wrapped and ready to go as in a package, then you can just build it. Yeah.
Okay.
I mean,
So So even if a current Linux package is not for ARM processors, it should
Which
be
I believe
available.
there is one for it, but yes, if it wasn't, for example, yes.
You could compile it. Okay,
Yeah,
very
yeah,
good.
yeah.
Thank you. That answers my media question. I'll probably save some others for after the recording stops.
Yeah. Anyone else? Okay. Again, John, thank you for doing this talk, at least on the recording. And hang on, and I'm going to start the recording and let everyone know when it's off.
Excellent. Thanks so much.